So today we'll be presenting an application, the hiking navigator application that we built on an A-star algorithm as a part of our final project for CS 5800, our algorithms course. It'll be myself, Bhumika Yadav, and Ishan Chaudhary in this project. So what is A-star algorithm? A-star algorithm is used to find the shortest path between two nodes, let's say a source node and a target node, and it uses informed search using cost and a heuristic estimate function. And it is basically a combination of Dijkstra's algorithm and greedy best first search. Who invented the ASR algorithm? Peter Hart, Nils Nielsen, and Bertram Raphael created the ASR algorithm, and it was developed in the Stanford Research Institute. And the original motivation for the invention was to help Shaky the robot navigate rooms optimally. It was created in 1968 and it was published in the paper called A Formal Basis for the Heuristic Determination of Minimum Cost Paths. So, some applications of the A-star algorithm include GPS navigation, robotics, video games, flight planning, and delivery and logistics, where it find the optimal path and the shortest route from one source node to the destination. So more of the pseudocode and implementation demo will be covered by my friends Bhumika and Nishan.
Now we will analyze the A-star algorithm. The algorithm guarantees an optimal path when the heuristic is admissible, meaning it never overestimates the true cost to the goal. In our hiking navigator, we use Euclidean distance, which fits the requirements and ensuring correctness. Now we'll move to the space and time complexity. In terms of efficiency, A star has a worst case time complexity of O of B power D, but with a good heuristic, it often much closer to O of n log n, which we achieve in our grid maps. The major limitation of the algorithm is its space complexity, which is roughly around O of m cross n for a grid because it stores all open and closed nodes. So this becomes very challenging for us when we handle the large maps. Overall, A star balances flexibility and efficiency very well for our hiking navigator use case. Now, over to my friend Ishan to show us the implementation and the demo part.
Okay, I'll start the implementation. In this project, we implemented the A-star algorithm to find the best hiking trail between 2 points on a map. The map has different terrains like flat land, forest, mountains, water, and scenic spots, and each of these has a different movement difficulty or cost. The A-star algorithm chooses the best path based on a combination of four factors: distance, where shorter paths are preferred, elevation changes, where steep climbs are harder, scenic preference, where it favors beautiful areas if users want, and avoiding water if the hiker prefers to skip water crossings. We also allow users to click and select start and end points, and the app calculates the best route which is possible. Now I'll talk about the experimentation part. We explored how A-star performs across different terrains and user preferences. We ran experiments focused on three areas: terrain complexity, elevation effects, and scenic preference. In our first experiment with varied terrain types, and we set up map including forests, mountains, and water bodies. So here, water body, as you can see, is set yes. So we'll be avoiding water body, and we all can see that in the route which we got is skipping the water body. Now let's move to the second experiment, that is elevation effects. In the screenshot pasted, the elevation weight has been increased to 5, And as a result, we can see now we are skipping the mountain areas and the hills part, and following the route we got is following the forest part. In experiment 3, the scenic preference, we manually added 10 scenic points. So the best route we got here is covering two scenic points out of 10 points, and is the best and the optimized route we got. The A star algorithm is very efficient as compared to Dijkstra or BFS, and it is very optimal as it guarantees the best possible path. That was about the conclusion from PPT. Now I'll walk through some of the part of the code. Um, so this is our main function in which here what we are doing with this generate terrain function. We add forests, mountains, and water bodies to what was originally just a flat piece of land. This gives our map more variety and makes it look more natural. Then generate elevation. In this, we create hills, adjust mountain heights, build elevation differences to make the landscape feel more realistic. And then in function add trails, after setting up the terrain, we carve out hiking trails. We draw random paths across the map while making sure to avoid water bodies so that trails stay walkable. In add points of interest, we place scenic points of interest along the pass. These are mostly placed at higher elevations, giving hikers beautiful spots to stop and enjoy the view. Now coming to the function handle events. While the map is running, we handle all user interactions. Whether someone clicks, presses a key, or tries to set a start and end point, we capture those events here. Now coming to the calculate path function. Here we calculate the best possible hiking path between the 2 points using A star algorithm. This is the main code, the main function of A star A star path finding. Here, here we are exploring different paths intelligently and finds the one of the best balances between distance, elevation, and scenic value, while avoiding obstacles like water. In calculate movement cost, we are exploring from when we are exploring from one point to another, we calculate the movement cost. This takes into account things like terrain type, elevation changes, and whether there are scenic bonuses on the way. Here in draw function, what we are doing, we finally are drawing our route, what we want to display, that contains the terrain, the pass, and the visited nodes, and all the extra details so that the map looks complete and interactive for the user. I'll show the application thing. So this is our application. Here we can see the green part is the terrain area, and I'll show in this way. These brown, orange color are the mountain areas, and circular blue points are the scenic points. If I want to start from this point and want to go to somewhere here, then it does show like skipping the mountain part and going across the forest part to reach there. If I move closely from here to this point, then it shows like it is covering the mountain part and also going to scenic points and uh, avoiding the distance to cover, like if it has to cover all the way across the mountain, then it will be the cost will be more. So this was all about from the project we made. Thank you so much.